Today is the 11th lecture on software quality assurance. In the last lecture, we talked about what software design is and what is the importance of the software design process in software quality assurance. We also said that software design is used in two contexts. One is software design process, and the other is software design model. And both of these have direct relationship with software quality. We need to follow a software design process which will result in the development of high quality software design model. We also discussed the fact that software quality is fostered in the design process, and if we don't give proper attention to quality in the design process, we will definitely end up with a poor quality software product. So we have to have an overall commitment in all aspects of software design for quality. In today's lecture, we are going to discuss design process and software quality assurance, as well as design model and software quality assurance in quite a bit of detail. We will look at the principles and guidelines, and we will also discuss some of the design concepts which can, if applied, will definitely improve the quality of software designs as well as the quality of the software product. These two things are intertwined. These are dependent on each other. You cannot have high quality software product without having high quality software designs. So let's begin our discussion on these two important aspects of software design, that is the design process and the design model. First, we will talk about the software design process. You have to remember that software design, that is the software design model, sits at the kernel of software engineering activities and is applied regardless of software process model, and it is the core part in developing a solution for the software problem. The process that creates that model creates a design model which consists of four things. It creates a data design, it creates architecture design, creates interface design, and it creates a component design. So we can say that a design model will have four components to it, four parts to it. Data design transforms the information model developed in the requirements and the analysis activities into data structures that will be required to implement the software. Data is usually the most stable part of an application domain. Lot of care has to be given in the design of data structures. We had discussed in the previous lecture different kinds of design defects, and we also looked at the data elements which contain many design flaws and many design defects. And we also discussed the fact that this is a fairly common problem, that care is not given to designing appropriate data structures. And so data design sits at the heart of the stability of the design model, and proper care and attention must be given to the development of data design. Next is the architectural design. It defines the relationship between structural elements of the software. The structural elements are those elements which when combined together, form a structure. So you can say that architectural design is a skeleton of the overall software design and the overall of the software product, and it captures the relationships between large subsystems in that software application. And so architectural design gives us an overview of, or provides us an overview of what the design would look like when it's finished. Then we have interface design. Remember, we talked about interfaces being one of the areas where design errors originate, and design errors create lot of problems for testers. So interface design also needs attention and care. It describes how the software communicates within itself, that is, components within components that are contained in the software, with systems that it interoperates with, and with humans who use it. The interface implies flow of information. And so the entire interface design, user interface design, would come under the interface design component of the software design. Then we have part of the software design, component design or component level design. This design transforms the structural elements of software architecture into procedural description of different software components. And this can also be labeled as detailed design. And from this design, programmers can write the code which will then convert this design into an implementation of the requirements. In order for us to achieve a good design, all of us, all involved in the design of software products, have to think the right way about how to conduct the design activity. This is very important. This is the guiding path of how a process should be conducted in software design. Let's now discuss some design principles which will help us in thinking the right way, in following the design process accurately. These guidelines, these principles have been developed by researchers and practitioners in software engineering over the last 4 decades, and they are a very useful tool for us to improve our design skills, to improve our performance in coming up with high quality design. So what are these principles? Number 1, the design process should not suffer from the tunnel vision. You know what the tunnel vision is. If you happen to drive into a tunnel, you notice that the vision is very limited. You cannot look on the right side or on the left side. You have to focus only on the path ahead, because there is nothing on the right side except walls, or nothing on the left side except walls. And if you try to look on either side, there is a possibility that an accident can happen. So you only can focus on the way ahead. Now the advice here is the design process should not suffer from the tunnel vision. The design process should be open, and we should look at different alternatives to improve the design process. We should not just blindly follow the steps documented in the process. Since design is a creative activity, we should try new things, augment the existing methods, and develop heuristics on following different design steps. So again, I repeat, the design process should not suffer from the tunnel vision. Secondly, the design should not reinvent the wheel. That is, if certain steps, certain activities have been successfully performed before, we should use that experience to avoid reinventing the wheel. This applies both to the project and as well as to the process. If we are successful in performing one activity, and a similar activity is to be done again, then we don't need to follow or create a new path for that activity, unless the objective is to find and unless the objective is to improve the process. The third very important principle is that the design should minimize the intellectual distance between the software and the problem as it exists in the real world. The software is obviously a solution. It is a solution to a problem that exists in some application domain. So even in the software solution, we should try to use the same terminology. We should not create new terminology, but rather use the same terminology that exists in the application domain. This will only happen if the designers get a reasonable amount of domain knowledge and are comfortable with using the domain terminology. The next principle is that the design should exhibit uniformity and integration. What this means is that even if a large number of designers are involved in creating design and design documents, it should appear as if only one person has developed the design document. The nomenclature, the notation, the style of writing, the terminology, the use of terminology should be all such that they are integrated and uniformity is present in the design model. This will give a very good impression that the design document is internally consistent, and also it will enable the programmers to understand the designs better, because they only have to understand one type of design nomenclature. If different people use different ways of documenting design, then the developers will have great difficulty in understanding and there's a possibility of misinterpretation, and that will result in creation of errors. The next principle is that the design should be assessed for quality as it is being created, and not after the fact, and not after it has been put for implementation. And so if we assess the quality of software design while we are still in the design activity, that way we can save money and time in the removal of defects, and the quality will improve with each application of software quality assurance techniques. The next principle is that the design should be reviewed to minimize conceptual or semantic errors that can creep into the design products. This again deals with the knowledge of application domain. Conceptual errors usually creep into software products, whether they are requirements or design or coding, because the developers or software engineers are not fully aware of the application domain. And so again and again I am emphasizing the need for software engineers to learn about the application domain in which they are working. So one of the things that the design work products should be reviewed is to minimize the semantic errors that can creep into these work products. Now let's consider the fundamental principle that applies to everything in life, and that is, when you apply these principles, plan for change, because change is inevitable. Secondly, you have to plan for failure, because all non-trivial software systems have defects in them. So these were the principles. Now let's see how would we know that the design that we have developed is of high quality. We will do this, discuss these guidelines in two steps. First, we will talk about guidelines to evaluate the software design process. So the first guideline is that the design must implement all the explicit requirements contained in the analysis model, and it must accommodate all of the implicit requirements desired by the customer. This again would require quite a bit of domain knowledge on part of the designers. The second is that the design must be readable and understandable guide for those who are generating code, that is programmers, writing test cases, these are testers, and for those who are going to test the software. So in testing we have two kinds of people: test planners who are writing the tests, and then testers who are performing the action of or activity of software testing. The third guideline is that the design should provide a complete picture of the software, addressing data, functional and behavioral domains from an implementation perspective. These are the guidelines that will drive your design process to success. We apply those principles and we keep these design process evaluation guidelines. Have we followed these guidelines or not depends on the success of the depends on how we execute the software process. This concludes our discussion on design process. But before we jump into the design model and representation, let's just summarize what is the importance of design process. Remember that software design is a heuristic and artistic activity. Designers over the years have developed certain quality concepts which can help us improve the quality of the software design. However, we must do that in a methodical fashion. We must follow the design process principles and continuously evaluate the process that we are following using the guidelines that we have just discussed. What will happen at the end of the design process, that we will get a high quality design model. That model will then be implemented in using any programming language or multiple programming languages by a set of programmers, and then the output of that activity will be tested for compliance to requirements. So software design is not only the first step in achieving the solution of a software problem, but it also requires us that we commit to a high quality software product when we start our design, both in the process as well as in the design model. Let us now discuss some principles that will help us in creating high quality design models. Number one is the concept or the principle of separation of concerns. What this means is that if one thing is not concerned with other thing, or one component is not concerned with other component, they should not have access to each other, or only limited access is given so that they meet their requirements. This is a very important and fundamental design principle. Second is modeling real-world objects. Whenever we are in the process of developing a software solution, we have to go through a lot of intermediate steps. The first is requirements engineering processes. In that process, we only talk about what the system should do. The next major activity would be the design activity. Now, the requirements are mapped onto the design, and we start adding solution-specific things because we want a high-quality software product. So, when we make this transition, we should ensure that in this transition we don't lose the domain-specific knowledge. So if an entity exists in the application domain, it should be available, or there should exist an entity in the design which models that real-world entity or real-world object. Another very important design principle is that we should try to minimize the interaction between highly cohesive design components. That is, we should have minimum interaction among different components in the software design. This does not mean that the components should have no interaction. Otherwise, we will not have a system. But interaction which is minimal will help us reduce dependencies on each other. Another very important principle is that the design should be traceable to the analysis model. Here we have to ensure that the entities and objects and other aspects of software design which exist in the design work products can be traced to the requirements as they were documented in the requirements document. The design should be structured to accommodate change. The fact of software engineering, the fact of life in software engineering is that things change. Requirements change, as a result, designs change. So the designer should design the product in such a way that adding new things or modifying existing things in the design is not very difficult. There are always two aspects of an application domain: those things which are stable and those things which are volatile. The things which are stable generally don't change, or if they change very sparingly. And those things which are volatile change very often. So the design should accommodate these two concepts. Another important design principle is that the design should be structured such that if it had to degrade, it would do so gently, and it would just not crumble if something bad happens to it. And so in cases of aberrant data, some unexpected events or unexpected operating conditions, the design should be structured in such a way that it can handle those things and degrade the application in a very gentle fashion. Another very important principle which is often, I wouldn't say often, which sometimes is ignored by programmers is that design is not coding. Design is design and coding is not design. So the level of detail that has to be recorded with design has to be of higher abstraction, and the level of detail in coding is obviously the final detail that can be provided for a software solution. So these were the design principles that have helped a lot of designers in achieving high quality software designs. Let us now talk about some guidelines for high quality design model. Number one, the design should exhibit an architectural structure that has been created using recognizable design patterns. Number 2, a design structure that is composed of components that exhibit good design characteristics or good design qualities, and a structure that can be implemented in an evolutionary fashion, facilitating implementation and testing. These are the guidelines that will help the designers to evaluate their design model as they are creating those design models. We had discussed some guidelines for evaluating the design process. Now we are discussing the guidelines for evaluating the design model. So the first is that the design should exhibit an architectural structure that has been created using recognizable design patterns. You know that design patterns have been very popular in the software engineering community because they enable us to document designs and to capture those recurring problems that exist in many different application domains. And if we use design patterns, we can use existing solutions, existing designs, but modify them according to our current needs. A design structure should consist of those components which have been developed using good design characteristics or good design qualities. And these are the design attributes that we will discuss later. The design should be developed in such a way that it can be implemented in an evolutionary fashion, and evolutionary development is now a very popular and effective way or process of software development. The next guideline is that the design should be modular, that the software should be logically partitioned into elements that perform specific functions and subfunctions. What this means is that the software should not be designed in such a way that it is all one big program or one big class or one big monolith type structure that has everything in it. It should be logically separated. It should have distinct representation of data, architecture, interfaces, and components, as we have discussed before also. The design should lead to data structures that are appropriate for the objects to be implemented and are drawn from recognizable data patterns. We have talked about design patterns before. Here we are talking about data patterns. For example, every person has an address associated with the person, which records the residential address. Typically, the fields or data elements in the residential address are a repeating data pattern. There is usually a street address, usually a city or a district or postal code. These elements can be formed into a structure which can then be reused, and that structure would be a meaningful structure, not just a collection of data elements. So designers should look for meaningful data patterns in application domain in which they are working in. A similar point to the one that we had already discussed is that the designers should look for components in the application domain which exhibit functional independence. That we have talked about we have talked about components which are modular, but here we are saying that with modularity, each module or each component should have some functional independence to it. It should do something or capture some information which is not captured anywhere else. A design should lead to interfaces that reduce the complexity of connections between modules and external environment. This helps us in keeping the interface problems or interface errors at a low number, and interface mismatches will reduce. This will also enable us to develop components which are dependent on themselves, that is, are not dependent on others, so that they have to get information from other components. The design should be developed using a structured methodology that is driven by information obtained from software requirements and analysis. That is, the information model that has been developed in the requirements activity is available for design, and we should extract that information using a method or a process which is repeatable, that we can apply again and again. The objective of this guideline is that the mapping, the transition from analysis to design or from requirements model to design model should not be ad hoc. It should be a systematic approach, and approach that can be repeated in the development of the software design. The guidelines that we have discussed just now help designers enormously in developing high quality software designs. Designers apply these guidelines with the help of fundamental design concepts or quality concepts related to software design, which will improve the internal and the external quality of the software design. Let us now discuss the quality attributes or quality concepts as they relate to software design. But before we do that, let's lay out 3 questions. The answer to these questions would be provided by the design concepts that we will discuss. The questions are: what criteria can be used to partition software into individual components? That is, how would we use modularity? How would we divide software into different components? How is function or data structure detail separated from conceptual representation of software? And thirdly, what uniform criteria define the technical quality of software design? These are the 3 questions which will be answered by the design concepts fundamental design concepts that we will discuss now. The beginning of wisdom for a software engineer is to recognize the difference between getting a program to work and getting it right. These are the words of Michael Jackson, a very famous researcher in software engineering. The design concepts that we are going to discuss now are going to provide the necessary framework for getting it right. That is, getting the software design right, or to produce highest possible quality software design. The first design concept that we are going to discuss is abstraction. Abstraction permits us to concentrate on problem at some level of generalization without regard to irrelevant low-level details. So it allows us to choose the level of detail that we want to and describe and discuss any concept, any problem, whether that's a software problem or any other problem. Use of abstraction is a fundamental way, a fundamental application in our daily lives. Grady Booch, who's a very famous writer and researcher in software engineering, once said that abstraction is one of the fundamental ways that we humans cope with complexity. And so for us to choose the level of detail and ignore the details at some other time for another discussion helps us to focus on different ideas or different concepts at one time. At the highest level of abstraction, a solution is stated in broad terms using the problem-oriented terminology. And we use the problem environment. That's why we have at this level requirements where we talk about what the system should do. We try to use the application domain terminology. We try to avoid the computer science or software engineering terminology. And so we are at the highest level of abstraction in the requirements. At the lower levels of abstraction, a more procedural orientation is taken. Problem-oriented terminology is coupled with implementation-oriented terminology in an effort to state a solution. And so that is where our design lies, that we are mixing the problem-oriented terminology with solution-oriented terminology. We are making the transition from what to how. At the lowest levels of abstraction, the solution is stated in a manner that can be directly implemented. And so as we grow and into the design activity, we move further and we try to then implement the design using any of the computer languages. That's where we don't talk about what has to be done. We talk about how it will be done. And that's the lowest level of abstraction, as far as humans are concerned. And so this concept of abstraction is a very important concept. And if you want to become a good designer, if you want to produce high quality software, if you want to produce high quality software designs, you must apply this abstraction. Then we have types of abstraction. The first is the procedural abstraction. It is the named sequence of instructions that has a specific and limited function. For example, if I want someone to go from here and open a door, all I have to say is open the door. I don't have to say go from here, grab the knob, move the knob, then pull it towards yourself. That is how you open the door. No, I just tell the person to go, or even just say open the door. And the rest of the details are suppressed or hidden. The second kind of abstraction is data abstraction. It is a named collection of data that describes a data object, any abstract data type, any object. That would be considered data abstraction. Thirdly, we have control abstraction. It implies a program control mechanism without specifying internal detail. For example, I can say synchronization semaphore, and with that I'm just conveying the concept and suppressing all the details that are associated with a synchronization semaphore. So this concludes our discussion on abstraction, but trust me, you have to learn it if you want to develop high quality designs or to evaluate high quality designs. The next is refinement. A program is developed by successively refining levels of procedural details. A hierarchy is developed decomposing a macroscopic statement of function in a stepwise fashion until programming language statements are reached. What this means is that you have a concept, and in the next step you add more detail, in the next step you add more detail, in the next step you add more detail, and at the end you have programming languages running, the statements written in programming languages. So we can say that refinement is a process of elaboration. You are elaborating things, you're adding details in each step that you take. There's a tendency on part of many of the designers and developers to move immediately to full detail, skipping the refinement steps. This leads to errors and omissions and make the design more difficult to review. Perform stepwise refinement. Don't rush while you are refining your designs. In fact, if you have paid careful attention, you would agree with me that abstraction and refinement are complementary concepts. In one place, you are suppressing details. In one concept, you are adding details. Then comes the most misused terminology in software engineering, and that is modularity. One of the oldest concepts in software engineering and software design. Software is divided into separately named and addressable components, often called modules, that are integrated to satisfy problem requirements. Modularity is the single attribute of software that allows a program to be intellectually manageable. We have already talked about the concept of logically partitioning software into different modules. However, you should remember not to over-modularize. If you do that, the simplicity that you achieve in managing these modules will be negated by the process of integration. In today's lecture, we have talked about software design process and software design model. We talked about the design principles and guidelines as they apply to both of them, and we were able to look at some design concepts which result in high quality software. You can also call them as quality attributes of software designs. We will continue our discussion in the next lecture on quality attributes of software design. Until then, Allah Hafiz, I take leave of you.